Welcome everybody to the MP Buffer Files course from eApprentice. What we're going to be talking about is how buffer files work in the MP language. If you've got your copy of the MP documentation portfolio and you look inside the MP documentation portfolio, one of the PDFs that is contained inside that file is the MP Reference Guide Volume 2. So we're going to be using the MP Reference Guide Volume 2 and also taking a look at the X7 NCI and parameter reference to go through all of the information about buffer files. So I'm going to go ahead and open up MP Reference Guide Volume 2. And the third chapter is on buffer files. So, we're going to be using the MP documentation as the reference material for this course. That way we make sure that everybody's got access to that data. So, what are buffer files? Buffer files are files that you can use with the MP language as a place to store and retrieve data. The three main uses for buffer files are as a place to store temporary data, a way of entering data that cannot be entered using an NCI file, and a way of outputting data other than to the NC file. There are two kinds of buffer files. There are string buffers and there are real number buffers. Something that's not really mentioned here, but it is later on in the text. Buffer files are files that you initialize from within a PST file. So when you're writing your file, just like you would initialize a variable or a string select table, you initialize a buffer. And what that does is that tells MP that you want to use this data structure that exists outside of the normal post instruction list. And so what MP does, MPDLL, it goes out and it reserves a block of memory. And that block of memory is dynamic, so it can be expanded if necessary. And that block of memory is used to hold your string data or your real number data. So the data in a string buffer consists of records, each containing one string. The data in a real number buffer consists of records, each containing a specified number of real numbers. When working with buffer files, it is often helpful to refer to the data in a spreadsheet format to help illustrate the file structure. So if we look down here, this is an example of a string buffer kind of typed out in an Excel spreadsheet format. So this is a column. You'll notice this is column A. And these are the record numbers. Record number 1, record number 2, record number 3. And each of these records contains a string of data, whether that's a single character, multiple characters, all the way up to the string character limit. To MP, it's just a single string of data. A real number buffer contains rows, and you can have multiple values. Each value would be indicating the column structure here. So in this buffer example, visual example, the first record here has 5 pieces of data. So column number 1 is the first piece of data, column number 2 is the second piece, column number 3 is the third, column 4 the fourth, column 5E the fifth. So this is record number 1, and there are 5 records. So in other words, there are 5 columns of data in this first record. In the second record, we also have 5 columns of data. So this is the first record, second record, third, fourth, and fifth. Remember, these are records, and this is a row. So as we count down by rows, and the columns are referred to as records. There is no limit to the number of records that can be stored in a buffer file. So you could have potentially, hundreds of columns of data. Now keep in mind, when you read and write, and we'll be getting to that in a little bit here, you're going to be reading and writing one entire row at a time. Okay, so you can read. Now there are up to 10 buffer files that you can define. So you can define up to 10 separate buffer files, and you can read and write the data in each buffer in any order by using the buffer number and record number. It says, note, if you skip one or more records, again, you can think of as a record as a column space. When writing data to a real number buffer, the MP post executable will pad the uninitialized records with zeros. If you skip one or more records when writing data to a string buffer, MP will pad the uninitialized records with a carriage return and line feed. Okay. Defining buffers. Before you use a buffer file in a post, you must define it using the post function fbuf. The fbuf function starts in the first column and is followed by 4 parameters. The first parameter is a buffer number. It's buffer number 1 through 10. The second parameter is a flag to specify whether to convert the file into a text file when the posting has completed processing. If this value is 0, the buffer is deleted after posting. The third parameter is the number of real numbers per record, or 80 to define a string buffer. So before we get too much further, there is a change. There is an update to buffer files starting with the X platform. So I'm going to open up the MP documentation. And if we go to the What's New documents, and we look at what's new in X posts, there we go. Buffer type for fbuf. The defined buffer declaration, let me blow this up a little bit, has been modified to add a 5th parameter, which is used to define the buffer type. In previous versions, a buffer defined with a record size of 80 implied a string buffer. The 5th parameter will now set the buffer type as follows. 0 or missing turns it into a real number buffer, and 1 turns it into a string buffer. So that was a change that was made to get around this requirement. And that requirement was to use 80 to define a string buffer. So this 3rd parameter, it used to be that if you set that to 80, that is what indicated to MP that it is a string buffer. We no longer do that now. You can have a string buffer that has more than 80 characters per string line. So you can make this 256 or 312 or 400, 510 or 12 or whatever you need to hold however long you think your strings are going to be. So that is no longer a requirement to use 80. So you can ignore this now. You can now make this the number of characters that you want to capture per string. And there is now a 5th parameter After the fourth parameter, you add an extra parameter which indicates whether it is a string buffer or a real number buffer. A 0 indicating real number, a 1 indicating string. The fourth parameter is a flag. The flag specifies whether or not to initialize the buffer from a pre-existing ASCII text file. So if you have a pre-existing file and you want to read in data from an external data source, buffers give you that ability. Okay, so that's how you define a buffer. And we'll get to the practical examples in a minute. Initializing buffers. Buffers are temporary files that exist in memory while the post is running. The system creates them, fills them with temporary data, and frees the memory when the post finishes running. There are two ways to fill the buffer files with data. You can write data to the buffer while the post is running. Or you can convert an existing ASCII text file to a buffer file. To convert an ASCII text file to a buffer file, you must, first step, define one of the predefined strings, sbuffname1 to sbuffname10, with the name of the ASCII text file. And when they say the name of the ASCII text file, what they're really talking about is the fully qualified path and name to where that file exists. The string name will determine what buffer file the ASCII data is put into. And then you must define your buffer as shown below. The string must appear in the post before the line that defines the corresponding buffer. So in order to read an existing file, you must initialize sbuffname1 through 10 with the string that contains the location of your data. And that definition must occur before you define your buffer. And you'll notice here that on the fourth parameter it's set to 1, which indicates that we want to read data from an external file. For a string buffer, it'd be the same thing. We would initialize the sbuffname3 or whatever number of buffer you wanted to read, and then you would give it the fully qualified path, and then you would define your buffer below. In this case, remember that we could use more than 80 characters here, and we would just have another 1 at the end of this. So we'll go through that when we when we do our own example. String ASCII NCI files, string ASCII files. In string ASCII files, each line is equal to one string. Remember, that is the row number. These strings may contain spaces, so the following strings are all valid. This is a string, this is a string, this here is still a string, even though it's got numbers contained in it. This is still one string record. And this here, even though it's a line of numbers separated by spaces, is still one entire string. The system will truncate any strings more than 80 characters long to 80 characters. This is no longer done. This is depending on what you actually define the length of your string record as, it will use that as the truncation. So if you define your string with 256 characters per string, it'll let you go 256 characters long before it truncates it. Real number ASCII file. To create an ASCII file of real number records, put one record per line and separate each real number value with a space. ASCII files do not necessarily have the same number of reals per record as the buffer file. For example, the ASCII file may have 3 reals per record, while the system may define the buffer file with 2 reals per record. If the ASCII file has more reals per record than the buffer file, the system will ignore the extra reals in each record. If the ASCII file has fewer reals per record than the buffer file, the system will pad the record with zeros. So what are we talking about here? We're talking about reading data from an existing file. So if you have an ASCII file that has real number data in it, much like we saw above, we would need to have those real numbers separated by a space character. And if there was more data per row in our source file, it would ignore the data at the end. If there was less data than we had defined for our buffers, it would pad those extra numbers with zeros. So that's what we're talking about there. I'm just going to stop real quick, guys, and just check, make sure we don't have anybody still trying to get into the class who can't make it in. Okay, good. So we're good there. Okay. I think the next thing that we're going to do before we get into more technical info about accessing the buffer data, we're going to go define some buffers in a real post. So I'm going to go ahead and load the default mill. Mill default is going to use mpfan. So if we look down at the posts, mpfan.pst, so that'll be the fan, or that'll be, excuse me, the post that we're going to be working with. Okay. Yeah, it looks like we had Jay Lee join us. Welcome, Jay Lee. We haven't gotten too far in, and don't worry, all these classes are recorded, so you haven't missed too much. All right, so we're going to go to shared mcamx7, mill, posts. And mpfan is going to be the post we're going to use. I'm just going to make a copy of it here. That way we can always get back to the original if we need to. And this is the post that we're going to edit. So I'll go ahead and double click to open it. I'm using the Mastercam X editor from version 6, just because I prefer it better. And if we go and search for FBUF, it tells us that the specified text was not found. There are no buffer definitions that exist in the default mpfan post. If we wanted to add a buffer file, we would need to come down into this text section, and we would need to initialize our buffer. It doesn't really matter where you initialize it. So we could, for example, go down all the way past the string select tables, maybe to just before the variable formatting, say right here. And we could create a new section in our post. Okay, so I'll just create this new section right here. And we'll call this buffer definitions. Now, the only real requirement is that if we are defining a buffer that's going to read data from an existing file, in other words, we're not just going to fill the buffer with data ourselves during the posting process, then we need to define the buffer name ahead of the actual buffer definition. Let's do the buffer definition first. fbuff, let me get rid of the unnecessary pound signs there. fbuff, and then we've got 5 numbers. Okay, so let me pull up volume 2 here. Okay, so here's our info about what each one of these does. So it's the buffer number 1 through 10. So in this case, it would make sense to make buffer number 1. Why? Because we don't have any other buffers in use. You can use any of the numbers. So you could use buffer 3 or buffer 8 or buffer 10 if you wanted to as your first buffer. You don't have to start with one, but I recommend that you do start in numerical order. It just keeps track of which ones you've used and which ones you haven't used. The second parameter is the keep flag. This tells MP whether or not we want to write the data out as a text file when we are done. So if I put a 1 in there, that would indicate that we want to keep the file. If I put a 0, it indicates that we do not want to keep the file afterwards. Okay? The third parameter number is either the number of real numbers that we are going to store per row, or it is the maximum number of characters if we're going to make this a string buffer. So if we were going to make it a string buffer, we might want to use 256 characters. The fourth parameter is a flag that specifies whether we read the data from an existing file, which is external to the post and to the NCI, or not. So 0 would mean we don't want to do that. 1 would mean we do. And the fifth parameter is a flag that specifies whether this buffer is a real number buffer or a string buffer. A 1 indicates that this is a string buffer. So we're going to say define a string buffer with 256 characters per string. Okay? So that's all we need to do to actually define a string buffer. We tell it the buffer number. We say, do we want to convert this from an existing file or not? This is not. We tell it how many number of characters. We say, do we want to, this says, do we keep the file when we're done posting? This one says, do we initialize it from an existing file? So in this case, we'll say, yeah, let's keep the file when we're done posting. Okay, so we're going to define the string buffer, but we're going to save it as well. Up above the buffer definition, and actually I'm going to type in fbuff and then I'm going to hit Control Space. Control Space is a shortcut in the Mastercam X editor that will show you the list of predefined variables, and it takes into account what you've already started typing. So here we're typing sbuff, and you'll notice that it comes up with a list: sbuff name 1, sbuff name 10, sbuff name 2, 3, 4, 5, 6, 7, 8, 9. So these are the 10 predefined buffer names that we can use. In this case, I'll type sbuff name 1. We always use a colon when we're doing the initialization. And now what I'm doing is simply giving it the location of where I want it to write out this data when I'm done. This keep flag, the second parameter, I'm telling it I want to keep this data when I'm done writing data to the buffer so that I can examine what got loaded in there. Okay? And so what we're going to do is we're going to say, let's find a good location of where we can store this. How about ctemp? That works for me. Now, the buffer files themselves have a default extension. You can override that extension if you wish. So what we're going to do is we're going to say we want this to write it out into C \temp, how about buffer1. Now the default extensions for the buffer files are tx1 through tx10 or through tx0. So tx0 would indicate the 10th buffer. So tx1 is buffer number 1. We can do txt if we just want to make it a text file. We can do sub. We can make it a sub. We can make it whatever we want to. In this case, I'll just go tx1. And let's save that. So this is really just telling it where we want to store this data when we're done, because we're not initializing it from an existing file. Okay? So this is a string buffer that we've defined. Now, whenever you define a buffer, and we'll be getting to this when we go back into the text here. Whenever you define a buffer, generally you need to define some other variables that work with that buffer. So you'll notice here, accessing buffer data, accessing real numbers, there are some variables that go along with these read and write commands. Okay. Let's see here. All right. I was debating on whether we want to go into this right now, but I think we do. Once you define a buffer, you can read or write data using the buffer number and the record number. The post function wbuff is used to write a buffer, and the function rbuff is used to read from a buffer. Okay? All right, hold on one sec, guys. Okay, continuing on. When you go and define a buffer, defining a buffer by itself doesn't really get you anything. You need to also define some variables that can be used as the variables to store and retrieve data from the buffer. We'll talk about that. And it's also good practice to create some variables that act as your counter variables. And we'll talk about why you need a read and a write counter as well. So, for accessing buffer data, this is the format for writing and reading from a string buffer. So you have string name equals wbuff, which is write to buffer. You have your buffer number, and you have your buffer record number. Remember, the record is the row. For reading, you have string name equals rbuff, buffer number, record number. And that's writing, or excuse me, this is writing to, this is reading from. The format for a real number buffer is variable name equals write buffer, buffer number, record number. For reading, it's variable name equals read buffer, rbuff, buffer number, record number. Okay, and this all seems a little bit abstract until we get to see some real examples of it. We're going to come back to this, accessing real number buffer data. I think this is a good place to start explaining this concept. It says you can use either a variable name for the buffer number and record number, or a constant such as 1. However, you will usually use a variable name for the record number because every time you read from or write to a buffer, the variable that represents the record number is automatically incremented by 1. The exceptions to this rule are when you read record 0, or when you have defined buffer no index set to 1. In these cases, the system will not increment the variable. The variables that represent the buffer number and record number are not predefined, so you must define them in the post-customization file. And this is where it gets a little bit tricky. We'll come and look at this in a minute. In addition to reading and writing to the rows in a buffer, which are called records. In addition to that, we can read record number 0. So that is how we determine the buffer file size. It says if you read from a buffer file, you must not read beyond the last record written. If you do not know how many records, remember a record is a row, are in the buffer file, you can determine the number of records by reading record 0 of the buffer file, which will return a value indicating the number of records in the buffer file. So when you read this, you notice here it says size 1 equals rbuff 1, 0. This formula right here reads the size of the buffer, and after that line of code executes, the variable size 1 is going to hold a number, and that's going to be an integer which represents the number of rows in that file. Okay, so your integer might be 10, it might be 5, it might be 4,294. Okay, I mean, it could be a big number, but that is how you determine what the size of the buffer is. Okay? One thing that you'll see in this little example here, we have defined our buffer. This is defining buffer number 1. In this case, it is we're reading it from an existing file. That's what this one over here does. Oh, excuse me. No, that's the keep flag. Never mind. But this has 3 real numbers per record. We also define 3 other variables: size 1, RC1, and WC1. RC1 is typically the read counter variable, and then we put a number after it which indicates which buffer it's for. WC stands for write counter, and that is also number 1. And you notice here that we initialize both of these to 1. The reason that we initialize both of them to 1 is that the first time you write to a buffer, let's do this. Let's give us some variables that work with buffer number 1. We're going to initialize a variable called size 1, and we're going to initialize it to 0. And we're going to call this okay, variable to read the size of buffer number 1. Okay, and we're creating these two other variables, RC1 and WC1. The reason we initialize them to 1 is that when we write our first line of logic that reads or writes from the buffer, we can't really start, if we're doing an actual buffer read or an actual buffer write that's not reading record 0, then when we do that, we really need to start at 1, because every time we do that that formula that writes to the buffer, that variable is going to increment by 1. So let's go and let's do something with this buffer. Okay, we have told it that we want the keep flag on and we want the initialize flag off. Okay, so we are going to fill this buffer with data, and we're going to keep it when we're done, but we're not going to start out by reading any data other than the data that we define inside the post file itself. Okay? So again, we need to do something with this buffer in order for it to make sense. So we also need a string variable that we can use as the variable to read or write from this buffer. So if we said we want how about we start string buff1, and we're going to initialize that as an empty string. Okay, we're just going to call that the string to read and write from our string buffer, str buf1. And actually, you know what? We can we'll just get rid of those underscores. str buf1. That's our string. Okay, so now we've defined this buffer. It's got 256 characters per string record. Go ahead and save that. And now let's do something with that data. Let's say that we wanted to capture the tool comment, just as an example. We want to capture the comment from the tool, and we want to write this out separately. So what that means is that we need some actual data here, right? We need something to process. So we'll create an example file. We'll grab a couple of different tools here. Nice little drill tool path. Okay, and let's grab a couple more of these. Copy them after, and we'll just grab different tools. Okay. So now we've got kind of a basic program. It's got some tool changes in it. If we just post out that data as it is, let's see, it looks like we've got our tool table turned on, but we're not getting our tool comments out. So that would be a post change. Let's go fix that. Oh, you know what? I've still got this open. So if we go back to our settings for our tool table, tool info, we're going to say that we want the comments at the tool change. This is just so that we can see what Mastercam is creating for our tool comment. Okay, so now what we're getting is this big long comment string that's got a bunch of our data at each tool change event. Well, let's say that we wanted to do something different. Let's say that we did want only the tool table at the header of the file, but we wanted a separate file that had each of our tool comments. Let's go find where that code gets called from. All right, so if we go down here and we look at our tool comment, P tool comment, okay, it says if tool info equals 1 or tool info equals 3, then write this string of data. Okay, so let's do this. We'll just add another line here. If tool info equals 2, and we could use tool info, or we could come up with our own variable, right? We could have like if write tool buffer comment equals yes, then output our data. Okay, here I'm just using an existing variable and saying, all right, if it equals 2, you know what, we really want to output to our buffer. And so when we do that, we're going to do something that looks like this. First, we have to build up our string before we can write it to the buffer. So we're going to do str buff1 equals. And then what we're going to do is we're going to start building up our string. So we're going to do s open underscore prn plus, you notice we're not doing it as an output parameter here, we're actually building a string. So s open paren plus, now this calls, you notice here, pstr tool. Okay, all pstr tool does is call pstr tool down here. And it says if str tool does not equal s blank, and then it does this handy little conversion for us. What we're going to do is we're going to take this same idea and we're going to incorporate it into a string that we're building up. Now, in order for us to do that, we really don't want to manipulate this structure here, because we can't just call a post block in the middle of our string concatenation. That won't work for us. So what we really should do is come up with our own variable to capture this data if we need it to. So this is string tool, str tool. We're going to do str buf tool without the $sign on the end. All right, so what I'm going to do is set a bookmark here. We're going to scroll back up to where our buffer definition is, which is up here. And we're going to create a new variable here. We're going to call it str_buf tool. So this is going to be string to capture tool comment. So str_buf tool, we're going to copy that. We're going to set a bookmark. Then we're going to go back to our other bookmark here. And what I'm going to do here is say this. Up above this str_buf1, we're going to say if str tool does not equal s blank, okay, so that condition is if the string is not empty. If the string is not empty, what we're going to do is say that, I'm going to paste this in here, str_buf tool equals str tool. So we're taking the value from str tool and we're assigning it to str_buf tool. And then what we're doing is we're saying str_buf tool equals ucase str_buf tool. And actually, you know what? We can actually combine this. We can get rid of this right here. Because we know that if it's not blank, we want to capture that value anyway, so we can include the UK statement here. And then what we'll do is we'll say else. That means that if str tool is equal to s blank, we're going to say str_buf tool equals s blank. Why are we doing this? Why are we putting in this else condition here? The reason is that we are going to do a string concatenation. And so if str tool has a string in it, we want to capture that string. If it doesn't, we want to make sure that we empty the str_buf tool variable because we're including it in the string concatenation. So we're going to say s open paren plus str_buf tool. Because up above here, we've either set it to be the uppercase version of this string, or we've set it to be an empty string. So either it's going to add nothing, or it's going to add the correct tool value here after the open paren. Okay, so we're doing string concatenation here. str_buf1 equals s open paren plus str_buf tool. All right. Now we want plus s delimiter plus, you see how I'm just basically copying this data that we were just outputting right here? Okay, now here's a fun one, because here we're outputting this T note, and T note is really it's a numeric variable. It's not a string variable. So the problem here is that what we really want to get is the formatted version of T note, which is not necessarily that easy to do. Okay, because right now if we just output T note, it's going to equal the number of the tool, but it won't have the T in front of it. Let me see if I've got any info on this. I may. Yeah. Okay. So they did put it in, thankfully. There in the volume 3 of the MP reference guide, there is some information about using a new function. And the function is called dress string. It's DRS underscore STR. And really, the value of 2 is the most useful one here. Okay, a value of 2 will return a string that consists of a numeric variable formatted for normal output. So what we do is we say some variable equals dress string, then we have our mode, which is typically 2, and then we have the variable number. Okay, so let's look at what we've got to capture here. We want to capture this T note, we want to capture this T off note, we want to capture this tool length note, we want to capture this tool diameter. Okay, all this one, this one, this one, and this one are all numeric variables, which gives us a problem. So we want T note, off note, length note, and diameter. So length. So here's what we're going to do. I'm going to define some variables right here because it's handy for me to look at what I'm doing here and then write some stuff down. Then I'm going to cut this set of variables and we're going to put them in the correct spot. So what do we need here? We need buff1 T note. Now, interestingly enough, this is actually going to be a string. So we're going to do these all as empty strings. So we're going to do str T note, str T off note. Try and line some of these up a little bit. str TLNG note. And we want str TLDIA. All right, the reason we're doing these as strings is because we're going to take these numeric variables which already have formatting associated with them, and we're going to use that dress string function to capture the formatted variable string and use that when we do our string concatenation for output. So, yeah, we got a question from Donald. Could it be S note? Yes. Yeah, you could have what, as long as you're not replicating another variable name that already exists. Yeah, you could just, dump that down to S note, S off note, S length note. Yeah, whatever you wanted to do there. You could have it str1, str2, str3. You could be real simple with it. You don't have to have it be super complex, and you can do anything you want as far as the variable names here. In fact, let's just do that. Let's just make this easy, because we know we're just building up strings, right? So str2, str3, str4. Let's just do that. I think this will be as good an example as any. So I will cut those. We're going to go back to our bookmark. Okay, and we're going to put those down here. str1, 2, 3, and 4. Now, when we go back to our section here, what I'm going to do is add str1 equals dress string drs underscore str 2. We're going to use the constant value for 2. And then the variable we want to do first is going to be our t note. So we'll do t note. Okay. Then we're going to do str2 equals dress string 2. And we're going to do t off note. And you know what we can do here actually? Right now we're wrapping this in a condition if tool info equals 2. We can actually just take that all out and write the buffer regardless of whether we output the comment or not. So that's another option that we always have. So here we go, t off note. String 3 equals dress string to t length note. Dress string to TLDIA $. Can't forget the $, since that one's predefined. Okay, so we're building these strings, string 1, string 2, string 3, string 4. Now what we do down here, we've already done our str buff tool, sdelimiter. Now we just need to add str1, because we've already built str1 up, right, as the tool note. So we add str1 plus s delimiter plus str2 plus s delimiter plus str3 plus, yep, you guessed it, plus s delimiter plus str4 plus what? S close underscore PRN. Okay, so really what we're doing here is we're building up this big long string of data into one string name, strbuff1. So strbuff1 is gonna hold this entire string of concatenated data. And the last thing that we're going to do here, strbuff1 equals wbuff, write to buffer number 1 with wc1. This is write counter 1. So every time ptool comment gets called, it's going to run through this data. And actually, you know what? We're going to take off this condition here. We're going to make it write to the buffer no matter what. So every time this gets called, you know, this may or may not get output. But this stuff will. It's going to calculate all these values here. It's going to build up this string. And then it's going to write that string to the string buffer. So again, if we go and look at here, format for a string, string name equals wbuff, buffer number, record number. Now keep in mind, wc1, if we search for that, we've initialized it to 1. The reason you always initialize your read and write counters to 1 is so that you start writing or reading at the first record number. And keep in mind, that variable, every time we hit this, as soon as we return from writing that data, this value will be increased or incremented by 1. So the first time this writes, we write to record number 1. The next time we hit wbuff, we write to record number 2, because this value has been incremented. The next time we hit this, this will be equal to 3. Okay, so we've set this up now, and we've set up, oh, did I get rid of my other bookmark? Mayhaps I did, yes. Okay, so we are building our string to the strBUF1 variable, and then we're writing it to the records. And this keep flag, just make sure that I with the keep flag turned on, we should be able to save this to this file here. Okay, so let's save the post file. Let's go into Mastercam and let's post process. Okay, so now we output our file, right? Everything looks good. We didn't output tool comments, okay. And now we need to go check ctemp, and you can see that here is our buffer data. So what happened is every time it hit that P tool table post block, it grabbed all that data. Remember, we used the dress string function. Okay, so here again, we use this you know what, I want to remove that one, and I want to put one up here. Perfect. Okay, so this dress string took the value from T-note, it formatted the numeric portion, it added the prefix and or suffix, and it assigned it to str1. The same thing happened with str2. We took the value from tool off note, we formatted the numeric portion, we grabbed the, all of this stuff that was ahead of it, and we put it in there. And this is what we did with our string buffer. We wrote these string values, right? And then we just output it. And this is, a fairly simple example of using a string buffer. The only thing we did as far as using it was to just output it as an ASCII file, right? We didn't manipulate or sort any of that data or do anything else like that. To make this more useful, the other thing that we could consider is capturing maybe the operation number. Okay, if we go in and look in our documentation portfolio, and let's go search for (15.240). And I'm pretty sure I'm sick enough that I remembered what this is. Yep. Okay. Operation parameter 15.240 is the number of the toolpath as shown in the toolpath manager. Typically, these are numbered consecutively in the order in which the operations are listed. Keep in mind, though, you could select operations 1, 2, 3, hold down Control, and select operations 10 and 11. And in that case, obviously, it would skip the ones that are in the middle. Okay, 15.240. So what we're going to do, we're going to go down to the parameter section. And that's in P parameter. We're going to say if param code $sign equals 15240, then the variable, how about opnum, equals S parameter, and we're only going to capture one value. So we're going to capture operation number. Great. So now we need to go up. We can do this in our format statement here. Right here looks good. Okay, so our prefix is going to be operation space, and then we're going to output this as integer, which should be 4. And then the variable we want to operate that on is opnum, so that's our initialization. We can initialize in a format statement. And we may want something after the actual operation number to separate everything else. So what I'm going to do is I'm going to put in a suffix character, which is an underscore, to help separate our operation number from anything else that we're outputting. And then what we're going to do is use opnum down here. And we're going to say and actually I think we can actually include it right in here. So what I'm going to do is say DRS str to opnum plus. Okay, so I'm going to include that function as part of my concatenation line. I think I can do that. So let's see if that'll work for us. Make sure it doesn't blow up. And surprisingly, it didn't blow up. Okay, good. So now, if we reload the buffer, you can now see it says operation, tells me which the operation number, and then I've output an underscore after it, and then the actual tool comment. Okay. So, that's a pretty basic example of something we can do with a string buffer. In our case, we didn't really output anything in the post itself, right? We gathered this data together, we built up some strings, and then we output them to a separate text file. So that's just one example of using a buffer. Okay. We're about an hour and 10 minutes in. I think we're going to go ahead and take our first scheduled break. That way we can break up the recording. Before we do that, are there any questions about what we've covered so far? Okay. not getting any questions, which is good, I hope. So yeah, we're going to go ahead and take our first break. When we come back, we're going to start taking a look at numeric buffers. So how do we define them? How do we write data to them? All that stuff. Okay. All right, so let's see. It's 2:40 right now. Let's go ahead and take a 10-minute break. We'll come back at 2:50. Thanks, guys.